They're the industry-leading security intelligence and deep code AI. And best of all, it is free. Forever for personal projects. So definitely check it out if you have personal projects and you just want to see kind of what I've done before of how bad is my code. Whew, it's bad and it's a fun activity for a weekend. And our next one is Craft CMS. They're a powerful, flexible, and secure content management system made for developers, designers, and content creators. So it offers a user-friendly interface, allowing you to create custom websites, blogs, anything like that. Those applications can be tailored to your unique needs, which is a really great aspect of Craft CMS. And you can unleash your creativity and stand out from the crowd. So go check them out. Really great.
And you can thank Craft for tonight's tacos.
Woo! And then, of course, the space we're in, Ventec. A lot of you already have tables here. If you don't know what this is, we're a co-working space. So we have, for $100 a month, we have this beautiful space available. You come in, you take a seat, you work. Kitchen is available to you. They also have the options for a flex desk or a dedicated desk. So definitely talk to Brian if you want to know more. He knows a lot. I have the lobby pass. I've been enjoying it quite a bit more than I thought. Sometimes it's just nice to not be at home. All right, then a couple other things. The Deschutes Tech Guild, we love Cloud Beers. Cloud Beers is headed up by Matt Small. He's typically here. Today he couldn't make it. But they're doing so it's an informal get-together. You won't have presentations there, but just network, meet other people that are also in the tech space or want to be in the tech space. It's a really fun activity. And they go to a different brewery or pub or restaurant every month. They typically meet on the third Thursday of every month. We have a handy QR code you can scan to figure out when the next one is. They're also on LinkedIn. And yeah, if you want to know more, talk to me. I love going there. And then my personal project, the High Desert Museum. I'm a volunteer there. I love it, so I always like highlighting your things that we're doing at the museum. So right now, the Sensing Sasquatch exhibit is open. It's a really interesting exhibit that goes for the visual senses, hearing, smelling, all kinds of activities to learn how the indigenous folks in our communities think about Sasquatch.
Question.
Yeah?
Do they still have the free passes at the library?
Yes, from what I understand, they do. Great call out. Yes, check the library. If you have a library card, you should be able to get a free pass to the High Desert Museum. Every once in a while, I also get free passes that I like to give away to communities. So if you want to go and you would like a free pass, talk to me. Also tomorrow, they have an Indigenous Artist panel at 6:30 p.m. They're going to talk about a lot of issues for the indigenous communities and their integration here, or our integration with them, rather, in the High Desert. That is a registration event, so if you're interested, go online to their website and register. All right. Now this part we do every time, the Deschutes Tech Guild. By a show of hand, whose company is hiring right now? Woohoo! All right. So everybody who's looking for work. All right. Talk to the two people that have raised their hand earlier. Don't swarm them. Be polite. Be nice.
We're looking for teachers, so if you're not interested in teaching, don't talk to me.
Oh, all right. Just don't talk to him at all. All right. We also have a Discord. So what we're trying to do is not just give you this monthly awesome event, but we also want to connect with each of you and have you all connect to each other outside of these monthly events. So we have a Discord. If you don't know what Discord is, it's an online community similar to Slack. It started off primarily for gamers, but it's really morphed into all kinds of businesses use it now. It's a fantastic platform. We have different channels for different interests, different ways to chat. We have voice channels on there as well. And for the folks that are looking for work, if you're looking for help with your resume, hit me up on Discord. I love doing it. I've done it for a number of years now. So yeah. And then, I know we haven't even started this one yet, but I want to bring up our next meetup is on June 11th. Speakers are to be announced. We are finalizing them. Please RSVP on Meetup so we can make sure we have enough food. And yeah, use either the QR code or just hit us up on Meetup. I saw a lot of people have joined over the last few weeks on our Meetup. Very exciting. And with that, I'm going to give it over to our first speaker, Tristan. Woo!
Thanks for the intro. I'm getting messages from people at work right now, and I don't know if we have any Gen X folks in here, but one guy's just said to me, I'm Gen X, we were never loved by our parents and find happiness in work compliments. It sucks. Does anyone agree with that, or I don't know. I think I'm supposed to compliment him right there is what he's trying to, we'll see, I literally just got that right now. I don't know if Tony can hear. Tony's our remote presenter after me. I don't know if he can hear anything. Tyler?
Okay.
Do we have a mic anywhere, or should I turn it on here?
See, can you hear you now?
I don't know. Tony, can you hear me? I don't even know how I would find out if he can.
We don't know.
He says yes.
Okay.
So, cool. Between all of our devices, we somehow are making it work. And then,
Hi, Tony.
I think you're flipping the,
Ta-da.
there we go. Sweet.
Hello, can you hear me?
Figure out how I'm doing this. All right, so I'll introduce myself in a second. Topic, intro to Kubernetes. I wasn't really sure coming in what the experience is here. And I'm not trying to act like I'm like some guru or anything, but I just didn't know exactly where I should start. So I'm going to start with the basics on containers. We'll work our way up. How frequently are folks working with containers at work these days? Okay, cool. So then maybe it's good that
Yes.
I'll start there. Sweet. All right, let's hop in. This is what I'll run through briefly. This is going to be very high level because you start getting into 5 and 6 there, and like we could dive into a million different topics. So by the end of it, I have kind of suggested maybe follow-ups that anyone here wanted to do, or I could try to do some of them, or whatever. Some follow-up topics that might be good, and some things that might get a little bit more DevOps specific, because originally I thought this would have been DevOps Central, and then now it's Deschutes Tech Guild, or so I don't know what the scope is, but keep going. So real quick though, who am I? Tristan Cheever from Bay Area, from Richmond, California, if anyone has any idea where that is. Went to Cal Poly, San Luis Obispo. Anyone in here? Mustangs? No? Yeah?
1 year.
Which, 1 year? There you go. It counts. Was at Cisco for 11 years, bounced around the Bay Area, doing software and hardware stuff, fun hands-on experience with all the servers and whatnot. About almost 6 years now at Ferrum Health. That whole time here, yay, Bend, love Bend. Hobbies, hoop, home brewing, music, LCD sound systems going pretty soon, so we'll see how we can. All right. All right, fun stuff. We'll start with history real quick. I'm gonna run through this so it's not too boring. Let's talk about containers and how they started. 06, Google took the first real attempt at what we consider to be a container today. There's a lot of stuff preceding this I'm not going to get into, but they had processed containers, and that ended up turning into what's known as C groups, which is leveraged by kind of everything else down the list here. And then shortly after that, you had Linux containers, which was kind of the first complete solution that had concepts of leveraging the C groups, but also namespacing, trying to isolate your applications in these little containers. I'll dive into that a little bit more as well. Warden by Cloud Foundry 2011, they leveraged C groups and Linux containers, and so did Google's Let Me Contain That For You, which was a play on Let Me Google That For You website. That was the snarky one you could send to people when they asked you a dumb question. Yep, okay. Then Docker, everyone of course knows Docker. That's the one that really made the container ecosystem explode. That's the big name. Again, leveraging LXC, but then eventually coming up with their own libcontainer engine. And that's kind of what everyone starts building off of, moving down further. Only a year later, you have Kubernetes coming to the fold, and that was all about orchestrating containers. So how do we, take, instead of looking at one application that needs to be in container, a whole app stack, spreading them onto a bunch of different servers all over the place, scaling up, scaling down. So that's what Kubernetes we'll dive into, brings to the fold. 2015, now we need standards, right? So everyone's got all this stuff going on, but everyone's doing it differently. How do we actually make it usable by everyone? We need standards. We've got the Open Container Initiative by the Linux Foundation, by the Google developers who were involved earlier up here, CoreOS, and a variety of other people around the same time. CNCF, the Cloud Native Foundation, was also started by the Linux Foundation. And then you start having different runtimes. So Docker is one way you can run containers. Containerd comes out of the fold. They're extremely popular too. It's kind of pieces extracted out by the Docker folks and contributed to the open source community. And then you have cloud native starts actually adopting different technologies. So they would actually start incubating. They would give like seed money to a group of developers that are maybe doing Kubernetes. Not that Google needed seed money, but other people who are doing projects could get money from them. They're being incubated by cloud native. And then eventually, if they meet enough criteria, there's a way that the project gets like graduated. So as we'll see later on, this can be a good way of knowing if an option out there for a certain piece in your stack is worth looking at. Usually you kind of want to look at ones that are probably at least in the incubating state by CNCF, if not graduated. But that's not always true. It's kind of personal preference as well. I flew through that, but we're going to like talk about other pieces here. Any questions though about just the history component? Nothing technical yet. I'll dive into more technical. No, okay. All right, so containers, right? What are they? This diagram, and I'll try to get out of your guys' way, I'm sorry. This diagram is comparing virtual machines and containers because sometimes, or at least when you're initially introduced to it, it might not be clear what the differences are and why you might use one or the other. So the biggest thing you're going to see here is basically on the VM side, you have the guest OS layer, and then you have the host operating system here in containers. So a virtual machine is relying on that hypervisor, where you actually have a host OS underneath in your infra. And that could be whatever. It could be a Linux machine, a Windows machine, whatever. And then you can actually have completely different operating systems in the virtual machines. And they're all relying on the hypervisor. And so the hypervisor is actually emulating all the hardware underneath. It's providing virtual drivers. It's completely sectioning off your hardware, saying, this guy gets so much CPU and memory, and that one gets so much CPU memory, that one has so much disk. And effectively and almost completely isolating all of that. And so you have a lot of security wins with VMs over containers because of that. It's a lot harder to kind of hack your way out of the VM back to the host OS than it is for a container. And you can just have completely different operating systems and kernels as well. Containers, your container has to rely on the same kernel from the host OS. It's actually sharing that kernel. So this is a Linux kernel. These are all going to be Linux containers. You can't mix and match. But these will spin up a lot faster. They're a lot lighter weight. They can come up and down, which is really good for scaling in the cloud. They're also, they're simpler to deploy. That's a long story, but when you get into it, you can just kind of Docker run a container or containerd CTR run it, get that up and going easily on your existing system versus VM. It's a lot slower. It's a lot more painful to get up and running. These days, for the most part, the VM stuff is typically abstracted away by the cloud platforms, and you don't really worry too much about that. You're a little bit more focused on containers in most scenarios. So I already mentioned containers. Kind of the one drawback I'd say is, one, you can't mix and match the OSs. So if you need like a Windows container for some reason, a Windows app, it's got to be on a Windows machine. And then the security. There's a lot more security concerns here. A lot of containers, a lot of times people just run them as a root user. They have root access. They can like do anything on that file system. You can break out. Now you can be in the host OS. It's a little bit more dangerous. So there's a lot more rules kind of to think to follow with containers. Questions on that? Am I moving too quickly? No? Good? Okay. All right. And then one other thing to think about here with the separation is you've probably heard the term serverless a lot. So just some examples of things in popular cloud platforms, AWS, GCP, that you have to think about the VMs would be if you're using like EC2 or VM instances, then you're thinking about the shapes of your VMs, meaning like the amount of resources in them, how many you need. If you're using EKS, GKE, those are flavors of Kubernetes services from those cloud platforms. Again, you still have to consider the VMs involved. So like I know I'm going to run a bunch of containers somewhere, but how many VMs do I want in my pool? How big do they need to be? Again, the resources, CPU, disk, memory, how much do I need? Now if you go serverless, you're not worried about the VMs anymore. That stuff's just magically abstracted away. So Lambda and Cloud Functions, some of you guys probably use that, and that's literally just write like a web handler, web server handler. It's just a function that gets called. That's it. More recently, especially on the GCP side, Cloud Run is really picking up. So ECS and Cloud Run are ones where you can get back to just thinking about the container, but then underneath the covers, there's a fully managed Kubernetes cluster that's doing all the scaling and deployment for you. But you never have to think about shaping your VM at all. So you can just kind of craft a container that has like your application, your tools, your libraries in it. Just say deploy, say, hey, I want it to scale anywhere from 0 to 6 instances, and then based on the usage, it'll just scale up however many replicas you need. And if you have no activity, you can scale it down to 0, save some money in the cloud. All right, so single node orchestration. I'm starting there. Single node meaning one physical server or one VM, basically one host that has Docker running on it where you can deploy containers. Okay, so this Docker host, you can just think of it as a server. You've got a Docker daemon running there. There's literally just a docker.socket, old school Unix socket there. And then you've got CLI commands you can run to run containers or build images or pull images. So there's a registry. This could live anywhere. Usually it's like there's a public Docker Hub registry, right? You'll have different images out there for all kinds of, your common open source tools, Nginx, Postgres, whatever, right? Any open source project probably has a Docker image on Docker Hub. And you can basically use like Docker pull to pull an image down to your local machine. You have a local store or a local registry of sorts. And then now once you have the images, you can use Docker run to run instances of those images. So like I might have Postgres, and I actually want to run 3 instances of Postgres. So I'll have 3 containers. Images and containers, those terms can get kind of misused. People will use them interchangeably. And technically, you have the singular image, and then you can run however many instances of that in the form of containers. So then what you got going on here too, that Docker build step there, that's actually if you want to build your own image. So you could build an image just from scratch. Literally, the file says from scratch, and then you just can add in tooling and run commands. Or you can even take one of these and build off of it. You could take again the Postgres one. You can say from Postgres, and then there's some other commands that you can do in this file that will basically just add on to it. You might tweak some of the config. You want to bake in a standard config for your Postgres, or add extra tooling in there, like debug tooling or log collection, whatever. You can do all that, and then just say Docker build, and then you'll just have your own image in here. And if you want, you can even Docker push that up to a registry. You could push it up to Docker Hub or your own private registry for your enterprise, whatever you want, and then run it again. It's containers. So yeah, basically again the idea here is that you're isolating this stuff within the container instead of on the host. So you might be running a variety of different versions of Python apps, and you don't want to have a mess of all the Python tooling, your 2.x tooling, your 3.x tooling on your host, and people messing around with switching between virtual environments and all that stuff. You can actually just have the different images that have the different versions and your different applications. You can even have a base image that's here's our base Python 3.7 image, and then you can use that to actually make other images that have your different applications that rely on Python 3.7 and so on. So it's very modular in that sense. Any questions on this one?
Who typically runs the registries and who contributes the images to it? Like for the Postgres example you mentioned, could be coming from the Postgres community, or coming from the Docker community, or somebody else?
That's a good question. Yeah, so you'll usually have official images that come from that project. So like the Postgres maintainers will give you an official one, but then you'll have other users that will make their own flavors or concoctions. So that's one thing to be kind of wary of, I guess, is when you're looking for images, definitely see who's the one that submitted it. Like most of the time, you probably want to go with the official, but every now and then there might be a reason that someone's made a cool custom one you want to use. But you have to be careful what's in there, right? Yeah.
Or it goes away magically one day.
Yes, and then sometimes they disappear, and then yeah. So that's another thing too. Is if you are relying on an image and you want to make sure it never goes away, that's where people usually spin up their own private registries. So you can actually host your own private one, or you can leverage ones from your cloud providers. Like GCP, AWS have all their own image registries. So you can get the copies in there, and then typically people will have their app stack pulling from those. And Docker Hub, if it goes away, doesn't bother you. Good question. Thank you. Anyone else? No? Okay. Okay, one more example for single node is Docker Compose. So it's also from the Docker people, and it's going one step further in that it lets you orchestrate more than one image at a time, more than one container at a time. Again, I mix them together, but it actually is both. So here you can see services, and you can see that basically this is a YAML file, right? And so you've got a web service and a Redis service. Very simple example of a web DB pair. And so basically they've got two different things going on. For the web one, they decided to show in this example, I forgot where I got this from. I didn't cite it, sorry. They're building the web service just in the local directory, just dot. So they'll actually have a Docker file there and their source code. And then they're exposing port, so the application is going to be listening on 5,000, but then externally, when you run it on the host, it's going to be forwarding it to 8,000. And then there's a watcher you can do, which is basically configuring a hot reload, so it's looking at the local path and seeing if anything changes, and it'll just hot reload it. So this one is building an image locally to use for the container. This one is pulling the Redis Alpine image from Docker Hub. So if you don't specify like a full URL, it's just going to assume you're getting it from Docker Hub. And so the image names, you're always going to see like a name and a tag. So the tag could be something simple like that, like Alpine, which is a really lightweight Linux distro, or it could be like a Semver, 100, that type of thing. So that's how you can specify the exact image and version you want. Docker Compose, you just say Docker Compose up. It'll automatically build that, run the web, pull the image down, run Redis, and you'll be up and running. Some watch commands or flags you can use if you actually want to leverage that hot reloading. And so the wins here are, one, it's combining in building and running in a nice, clean, single atomic thing for you. It's also letting you manage multiple, so you can build up a stack here. But the deal is that the con is that we're still stuck with single node orchestration. All this is running on one server or one VM. If that server or VM has any issues or goes down, you lose the whole thing. The whole stack's done. You have no HA. It's not going to get, the workloads aren't going to get moved to another node for you and brought up, nothing. So you're relying on that single point of failure. Any questions on this one?
Great for local development.
Thank you. That is a great point that I didn't explicitly call. You're absolutely right. Usually you're going to use either Docker or Docker Compose for local development, stuff like that. Thanks, Tyler. Okay, so then now naturally we're moving to multi-node, right? So now we want to get that AHA, that reliability. We want to actually use something that will let us deploy these containers on multiple nodes, which again might be physical servers or might be VMs or a mix. They could even be a mix of in the cloud or in a local data center. It could be anything. So we also need the scaling. So not only do we want the ability to have these different services deployed on the different nodes and shifted around if a node goes down, but you might also want the ability for multiple replicas of something. Like again, if it's Postgres or Redis or DB, to handle the load that's coming in or the number of requests, you might need multiple instances working in a distributed cluster. And so you can get those distributed across the different nodes and all working together and automatically networked as well. Sometimes you want to actually have nodes that have different hardware offerings. So for instance, if you're working with ML, you might have some nodes that need GPUs for the ML workloads, and then other nodes that don't need GPUs. You want to save money because that's a very expensive resource in the cloud. So you can actually have a mix of those nodes and then use some functionality in Kubernetes to pair the right workloads with the right hardware. I'm already jumping to Kubernetes being the solution for that, but there are a few out here. These are probably three of the most notable before I go to managed platforms on top of Kubernetes, but at the base, Kubernetes would be by far the most commonly used. Some folks really like HashiCorp Nomad. I've only used it once briefly. I found it really difficult, but some people love it. And then Docker Swarm is like another evolution. You have Docker, Docker Compose. Docker Swarm brings the multi-node. That's actually made significant strides the last few years, and I find it a lot easier to use now. And you can get started much more easily than Kubernetes, but then the ecosystem is lacking in comparison. So just focusing on Kubernetes now, moving forward. There's a lot of different flavors and distributions of Kubernetes. So right when you thought we had to pick, it's like, no, now you have a bunch of choices of Kubernetes. So vanilla Kubernetes or Kates, KubeADM, it's just a CLI tool you download and you say, init, and it makes you a cluster. And if you're on another node, you say join, and it joins that cluster, that type of deal. Minikube or Minikube and Kind are very popular for kind of low resource, local dev situations. Then you have a whole bunch of these really heavy managed self-hosted platforms. You got OpenShift from IBM, Red Hat, I think. Platform 9, Rancher, and then the Rancher folks also made K3S, which is like a lighter weight managed platform. And then you got the cloud providers. They've all got one, right? AWS has Elastic Kubernetes Service. GCP has Google Kubernetes Engine, and so on.
Can I ask
So,
a really dumb question?
yeah, talk to me.
What is Amazon Elastic Container service do the same thing that Kubernetes does?
Elastic Container Service. So my understanding, because I'm much more familiar actually with Cloud Run, but Elastic Container Service would be the analog-ish. My understanding of that one is what's happening underneath for that is not actually Kubernetes. It's just VM instances that you don't have to manage, and then it's just like slapping the containers in there. That's which Tyler, I guess, is confirming I'm right. Yeah. But the Cloud Run analog would be the one that's actually there is a GKE cluster, an actual Kubernetes cluster underneath, but you like to have no idea, and it's just.
I kind of look at it as a lightweight Kubernetes.
ECS.
Yeah. You don't have command line tools other than the CLI and the set manager. You can't do orchestration. It handles it all on its own. So it's kind of unless you're doing EC2 instances with it, which most people don't nowadays, use Fargate to get the serverless stuff.
Yeah, I think maybe I meant Fargate. I kind of thought ECS and Fargate were the same.
Yeah, so ECS and Fargate are kind of synonymous now, but it used to be with ECS you had to run EC2 instances, but you would have to do that versus Fargate with that.
Okay, so then Fargate probably is kind of, you know, it's occupying the same niche in the ecosystem as Kubernetes, or?
Kind of. It's just Amazon's private sugar.
Got it.
So,
Cool. Thanks, Tyler. I forgot what my train of thought was, but that is all the flavors of Kubernetes. At the end of the day, I'll get to in a second, is an architecture diagram. The differences here are that there's slightly different options for some of the components that make up what people consider to be a Kubernetes cluster. And so like there's a proxy or a DNS server, whatever, and there's different options you can plug in there. So all of these kind of have different preferences for those, and then it's whatever sugar they offer on top, like especially the managed self-hosted and the managed cloud platforms. They offer all these other abstractions and stuff even on top of Kubernetes. So this is the diagram I was talking about. So, we were just talking about containers, right? And things seem like, okay, that's not so bad, it's cool, it's isolated, processes effectively. Now we got all this other stuff going on, right? So here's the nodes I've been talking about. And then you're gonna have these kubelets running here. I'm not really sure why Kubernetes people thought it was great to like make this legend instead of just putting the titles there, but whatever. So you got these kubelets, and then you got proxies on each one that are helping for proxying networking outside of the nodes and within the nodes. You got an API server here, you got a controller manager who's managing nodes coming up and down, or a cloud controller manager who's going to the cloud provider API to manage nodes going up and down, scheduler for scheduling your workloads, which is effectively your containers, and then etcd for a persistent store. And again, these are the things that can, there's different options for these, like you don't even have to have etcd for the store. There's different options for proxies. The DNS server is not even in this diagram. That there's Cloud DNS, KubeDNS. So it's mix and match, but then you functionally need these things, and you have a Kubernetes cluster. Let's talk about workloads. There's a lot going on here. This is straight from Kubernetes folks. Container, we're down here. Here's all the abstractions now we have on top of a container, right? So in here you have a process, and you got that thing isolated. It has a certain amount of resources given to it, some permissions and controls to isolate it a bit from the rest of the host operating system. There's a concept of init containers also that are also running in this pod together. The pod hosts hold these containers. So sometimes there's init containers that are basically things that are like setup. So you might have, let's say, a DB in your main container, and you have a init container that actually needs to do something like initializing the database cluster or setting up a username and password, right? So the init container will do that first, and then the other containers get run after. That's automatic, and that's all in this pod definition. All these things are defined by these YAML files in a very similar kind of format, and it's kind of beyond this talk to look at every one of those. But they have an API reference that will show you the YAML files and options available to you. So in the pod, in that YAML file, you'll say, hey, here's my one or more containers, maybe some init containers. Most of the time, you're probably just going to want one container in the pod. You still want to keep things pretty isolated. The exception to that would be there's something called a sidecar model that's popular for things like log collection or resource metric collection. And so that would basically be like two of these containers side by side running all the time in that one pod. And so one of them is like your log collector, and the other one's your actual application. Moving up from a pod, there's a lot of different ways you can get to having a pod. So probably the most common is right down the middle here. There's a replica set, which is basically says how many of those pods you want. And when I say how many pods, I mean like exact replicas of that. So again, just going to keep going with the Postgres example. Maybe I want 3 replicas that are all going to work in tandem. So replica set will say I want 3. You have deployment. Most people usually work at this level. The replica set just kind of comes for free magically. They don't actually explicitly define that. And the pod spec is actually crammed as a subset of the deployment. So as part of them doing this, they end up defining the pod, and then the whole thing just kind of comes together. When you have a deployment, at that point you have the ability to scale it up and down. It's kind of manual. You can just say like kubectl is the command line. I want to scale up to 3, down to 1. If you want that auto scaling, pod scaler, horizontal pod scaler. So horizontal scaling, right? Multiple instances of the same thing. You need more instances to handle more load, more traffic. So there are a lot of implementations out there. You don't have to do that yourself. You can go pick one off the shelf for one of those auto scalers. And then you will usually do things like say, when one of the pods gets to so much CPU or so much memory usage, I would like you to scale up to another pod, and then keep doing that as needed as the pod resource usage. Keep hitting that threshold. Stateful set, I'm not going to spend time on because I have never found that useful. Don't use it. There's probably a use case, but honestly, I've never found that useful. It's supposed to be a deployment with syntactic sugar, but then it isolates all the pods and they don't work together. It hasn't helped me.
Stateful set is how you deal with database ensembles. If you want to have a discrete number of databases in a group and you want to like have better logic about how you turn them up and down so that way you don't have things like clobbering masters or things like that, that's when you use a stateful set. There's lots of logic within that and appropriate syntax to be able to configure it.
Yeah, the thing that I've always found not helpful at all in that scenario is that the volumes are completely isolated. So you have disparate data sets now. So I'd rather have a cluster that's all feeding into the same distributed database storage. So that's why I've stuck with those. But I hear what you're saying. And I haven't even talked to you guys about what volumes mean, sorry. Volume, let me tell you what a volume is. A volume is basically just storage. So underneath these pods, you can actually define volumes that get mounted in. So at its simplest, you could just say, I have a volume at this directory, /data, and I'm going to mount that into my pod, into my container at some other path within the container. And so in reality, you're not going to just do your local directory. You'll use some storage service from the cloud platform. They'll have like a file system service or a database service, something like that. I'm not going to go over the rest because I think it's kind of overwhelming unless you'd like me to. But I'm covering a lot of ground here. And that's why I'm saying that I think there's a lot of separate talks you could have that you could dive into kind of any one of these areas.
Question.
All right, yeah, go for it.
So where in this hierarchy of abstractions do you specify the binding to the physical hardware? Be it raw metal or VM?
That's a good call. Yeah, so that would be in the pod. The pod is the one where you're going to say, I request this much CPU, this much memory, maybe even GPUs, and then storage, and where you will also set up your volume mounts if you have storage that you need to get mounted into the container. So you need some access from a file system somewhere, local or networked, or from object storage like S3 or GCS. You'll define that in the volume. That's a good question, bro. Thank you. Anything else? Okay. This diagram is from their website and is the highest res version I could find. And I find not even that helpful, but I'll try to walk you through some of this. This is looking at things from the networking perspective. So I have my nodes down here, and they have one network or subnet basically. Then in the black here are the pods that are running across those 3 different nodes. They have their own network. And the purple here is services, which I haven't talked about yet. So I was talking about the deployments on the previous one. What you have to add on top of that is now a service that hooks a deployment that actually exposes it, at least to the whole cluster, if not out through the nodes to the outside world. So you end up with 3 different sets of networks. And that's where that Kubi proxy piece that was in the cluster comes into play, because it's handling proxying all stuff from one network to the other for you. Kubi proxy, yeah. So, yeah, great diagram, right? Okay. This is just kind of a note for like if we show the slides. We don't need to go into too much, but this is just saying who assigns the addresses for the different pieces. So like I said, there's pods have IP addresses, services have their own subnet, and then nodes have their own subnet. So different components in the cluster do that fun work for you. It's worth mentioning that Kubernetes and Google folks and everything introduced some standard interfaces along the way. So you've got container network interface, runtime interface, storage interface. So these are just examples of popular things off the shelf that people choose. So again, there's like so many different things you can pick in the Kubernetes cluster. So like the CNI, this is basically handling the internal networking, namely for the pods, how they're going to get their IPs and then all communicate to each other. So you'll pick one of these CNI plugins. Flannel's usually the best simple starter one. The other ones are more feature rich. Runtime interface. How are you even going to run the containers? I mentioned earlier Docker, right? Containerd. There's also CRI-O. Those are all CRI compliant. Technically Docker's not, it needs a shim. But those are kind of the three most common, I'd say. There's another one, Rocket or RKT. I don't know anything about that one. And then storage interface. How are you going to access your storage, right? You might have stuff in object storage like S3 or GCS, or you might be using one of the cloud file system services like Elastic Block Storage or EFS, file store. So you need a CSI driver for whatever storage you're using. And all these things can be deployed as more pods effectively, more Kubernetes resources. They're all just spec'd out in these YAML files, and there's a Docker image behind it. You apply it, the Docker image magically gets run into a container, and boom, it's there. Super hard to read, but this is just showing you at a high level what I was talking about with the interfaces, namely the runtime. Kubernetes is here at the top. There's container runtime interface. Docker's over here. It does not have a CRI compliant interface. So you have containerd and CRI-O here. Some people are still using a Docker shim here for Kubernetes, so they can still use Docker as a runtime, but that was deprecated, I don't know, like a year ago. So you can do it, but if you don't want to rely on Mirantis to keep maintaining that shim, it is better for you to pick containerd, CRI-O, or any CRI compliant runtime, just heads up. And then OCI, that was Open Container Initiative that I talked about earlier that came from the early Docker days. And that interface is implemented by runc, or runc, however you want to call it. And you eventually get to a container. So the main lesson here is lots of layers of abstraction, many. Ton of stuff here, but these are additional things we could talk about that also go into Kubernetes clusters. How you get your data in the first place, extra security and load balancing within your pod network, tracing who's talking to who and how are the response times, how many requests, maybe figuring out there's too much chatter somewhere or it's too slow of a response. Telemetry for resource metrics, log collection, device plugins for other things like NVIDIA makes a device plugin so you can use GPUs in your pods and containers. And secret manager. I want to give my passwords around in a secure fashion. And here's an example of all the options you have. And then the scroll bar is halfway down. So there's two of those screens. So this is where I was talking about. You probably want to pick stuff that's CNCF incubated or graduated, because that's like these big ones, the big boxes, right? Then you only have like 3 or 4 options per concern in your cluster. Okay, and maybe some suggested topics here. We could dive more into the control plane, which was that stuff on the left that had the pieces that make up the core of Kubernetes, versus your workloads, which is like the containers and things you actually want to run. Maybe some networking, observability, some live demos in the cloud could be fun. Looking at you. CI/CD.
Future talks.
Secret management. Yeah, these are my suggestions, my humble suggestions for more future talks. And that's it. So I hope that wasn't too much. Any more questions from anybody? Yeah.
So based on that page of just like a million options, do you have any just like industry tested besides the incubator recommendation? But like even if you're down to 3 or 4, like how do you know which one to pick?
Yeah, that's a fair question. Can you go back? there's a lot of pieces here, but let's see. So, okay, first thing real quick, ingresses, deprecated, gateways, the new way. The cloud provider is just going to usually give you one of those, so you don't really have to pick too much. Service mesh, Istio is kind of the OG. They've been around forever, and they're still doing new kind of approaches. So that's a good name I'd look at. Tracing, I want to say Jaeger. Telemetry, maybe Open Telemetry, Open Metrics. Log collection, that might have been Jaeger, or is that tracing? Log collection, I can't tell you off the top of my head. Device plugins, that's going to be mandated by the people who make the hardware, so that's going to be NVIDIA.
Jaeger's going away. The new standard is the OpenTel platform.
OpenTel, okay.
OpenTel protocol.
Secret Manager, again, if you're in a cloud setting, that's going to come from your cloud providers. Like GCP would be, it's literally called Secret Manager. I forget what AWS might be, KMS. Is it also Secret Manager? Okay, they're just copying each other, cool. And then, just to give you a nice thorough answer, like I was saying here, like I would start with Flannel, the CNI. A lot of times you really are not, you don't actually need much more than Flannel. The only thing that might push it is the surface mesh that you choose, might push you into one of these other CNIs. Again, I would go with Containerd now, just to avoid relying on the third-party Docker shim. This totally depends on where you're living, what cloud platform. And then, going way back before, I really like kubeadm for just getting going on your own. Personally, over Minikube is very limited. And Kind is an entire cluster inverted in a Docker container. So I avoid that as well. Hopefully that was a good answer. Yeah. Anyone else?
Well, this isn't. Oh, sorry.
Go ahead.
Okay.
Go for it.
I was going to ask you if I could pick your brain later, but this isn't. It's not conducive to the group sitting here.
Sure. Anytime. Yeah.
So when containers first came on the scene, it seemed that one of the value prop was about reproducible environments and avoiding Linux package dependency hell, stuff like that, with the multiple versions of Python that you mentioned. But it seems that what you're describing now, that a lot of the value prop is the multi-node orchestration aspect, scale up, scale down. Is that fair?
Yeah, it's the combination. Yeah, I mean, you don't have to you don't have to worry about anything on the host anymore, really. Yeah. And like you're talking about with the packages and everything, and now you can just deploy, scale. Networking is kind of magically done for you. You know, you hardly ever have to think about how these different VMs and servers are talking to each other. Yeah.
With all the levels of abstraction that you get, show one of the slides. What do you do when stuff goes wrong? When the network automatically appears and we don't talk about care when it works. Good.
Yeah, I think you're just like aiming to get to it working so it can go wrong. No, I'm kidding. Yeah, I mean, it's tough. And so that's where those other pieces come in, like I was talking about with the logging collection and tracing telemetry. Like getting that visibility into what's happening in the cluster is difficult, but very valuable. You know, the cloud platforms are trying to abstract enough away where you don't have to worry about it. And that's why lately, especially on the GCP side, which I'm more familiar with in my job, Cloud Run is taking off because people were getting thrown into this Kubernetes cluster GKE thing and getting lost in it, and now you can get back to just thinking about your container. Yeah. And then it just happens to be running in GKE for you, and you never even thought about it. So
ECS target is the same.
Yeah, so they're trying to get people actually not having to think about it anymore because it went off the rails. I mean, it's a pretty wild ecosystem, yeah.
I would say for a good portion of folks, Cloud Run and Target are probably sufficient for most users. So when you get into service discovery, especially on ECS, that's where I live. It gets a little more difficult, and I kind of wish I had the Kubernetes method of doing all that stuff.
The other thing too, like to get back to your question about how to figure out what's wrong, there's so many layers, but a lot of it is that there is one particular suite of equipment managing one particular slice of the entire infrastructure, like a CNI. You know, you have a defined CNI, you're not going to pick like 5 CNIs and crush them in together unless you really hate life. You know, you're going to pick Flannel or Cilium and be done with it, and then you're not going to worry about it until you have a networking issue. And then you'll better be able to reason about it and say like, well, this is either going to be a Flannel issue or it's going to be something much bigger that's outside of my control because, you know, my provider for cloud, my cloud vendor is going to be doing something terrible. In which case, you know, You really should be shopping for a new cloud vendor, but it's highly unlikely that that's the case. It's going to be something small like that.
I would say 99% of the time when things go sideways, just look at the events logs and the container logs. I usually figure out pretty quickly what's happening.
Yep. I think someone else. No, you were going to talk to me later. Anyone else? Yep.
What are the security risks for running Kubernetes versus the VMs?
That's a big question. So, I mean, one, containers in general, as mentioned, there's a breakout risk. So a couple things. A lot of times people just run them as root, which is already kind of a bad start. So once you run them as root, whatever's running, whatever process is in that container, it's the same as being root on the host. And they can mess with your file system, possibly break out system calls with the kernel, the whole deal. So they can kind of mess with the entire host. So then, because of that, Kubernetes relying on those containers, those risks are there inherently in Kubernetes. That's probably the biggest area.
Not making your API server public?
For the Kubernetes cluster?
Yeah.
Yeah. That's the main way in for any admin to like control the cluster is the API server. So yeah, not making that public is a big one.
Yeah, Kubernetes by default is deny all, and you have to selectively grant access. So it's arguably way more secure than trying to spin stuff up on a host where you have a whole different variety of switches that can be thrown in a whole bunch of different
You just don't
ways.
hand out the root kube comp.
But what you were comparing was not VMs, right? You were comparing manually spinning up containers on your own versus Kubernetes, right?
Was that your question, Kyle?
Comparing to VMs, but
Yeah,
Yeah.
compared to VMs.
Yeah. So I mean, VMs inherently are going to be more secure just because the isolation is a lot stronger. Yeah.
Apologies, I misunderstood.
Man, come on.
There are strong arguments for the ability to secure Kubernetes just as well as you could at VM as well. But the biggest thing is teaching your developers not to use root permissions for things and go for the principle of least privilege for everything. So if you can get everybody to get on board with that, it'll be just fine.
Yeah. And there's good security scanning tools out there. So there's a really good tool called Lens, which is a really friendly UI tool for managing Kubernetes clusters. They have a simple one-click install this thing called Trivy into your cluster, and it's scanning right away all of your different images, your containers that are running, if they have any known vulnerabilities, if there's any security best practices that aren't being met, all that stuff. It'll just give you like a full profile of like, here's what you're doing wrong with your cluster. So, yeah.
Coolest Trivy is, Sneak is a competitor to Trivy, so we love Sneak.
Until they're in Lens. No, I'm kidding. Yeah. Anyone else? Yeah?
It's just sort of a weird question. It seems like it's a pretty steep learning curve, pretty complicated environment.
Yeah.
And so it's sort of like wondering, when does the scale and the bigness of your project make sense to start employing all this stuff?
Yeah.
Versus not.
Is that like a critique of my presentation? I'm just kidding. You're totally right. You're totally right. So like I said, it really comes when you get to multi-node. The second you have to break out of single node, you have to go to one of these orchestrators. You have to go to Kubernetes or Nomad or Docker Swarm. Blueboard, Clark chose Docker Swarm instead of Kubernetes, and they were up and running like a week or two. It was much simpler. But then the ecosystem is lacking. When he started needing, an already made, I'll just call it a deployment or an operator, but we'll call it a deployment. When they needed something they could just drop in easily to their cluster for some open source tool, it wasn't available for Docker Swarm. People hadn't crafted that yet, so he had to do it. That's the trade-off. But once you go multi-node, you got to pick one of these, or one of these abstractions we were just talking about. You go ECS in AWS, or you go Cloud Run, so you can still just focus on thinking about containers and not worry about the cluster. That would be probably a good ramp up.
The cost of EKS, which is Amazon's Kubernetes service, is it can be nearly double what ECS clocks. So if you're going to start off small, you just need simple orchestration for things, and you've got basic services. Start off with ECS, and then you'll probably find that you're not going to hit any sort of limitations. It's when you get to large scale orchestration that Kubernetes is where you need to go.
Yeah. Fargate's even cheaper.
Oh yeah, Fargate is just.
And there's a big full serverless movement right now too. So some people are just doing the entire thing in a Lambda and a ECS. Yeah. So they're not worried about any of this. They their entry point might just be a bunch of Lambda functions, cloud functions, or the containers.
Our other sponsor, Craft CMS, they have a whole install that's entirely in Lambda. It's pretty awesome.
Yeah. Got to move that to ECS though. gotta get that. Just kidding. Yeah, thanks, Brian. Anyone else?
Tristan,
Yeah, what's
so
up?
what about like systems where you have like very predictable load? Are there still sufficient advantages to justify it? Like say like a private like Internet of Things system where like you have a set number of devices connecting. Occasionally you add devices. You might want to spin up them, but it's never in response to like it's not a public website.
Yeah, so like the scaling part you might not need as much, but the HA you probably still want. So you still want the stuff to be deployed on these different nodes. That node goes down for some reason, gets shifted over automatic.
Just a declarative way of kind of stamping out your infrastructure is still compelling versus other options, even if you don't need the dynamic scaling.
That and also there's a whole area that I just completely glossed over because it's too much I think right now. But blue-green deployments, canary deployments, there's a lot of support for that as well. So you say, hey, I have V2 of the service I want to put out. I want 10% of my customers' traffic to go to that to test it out. You can do that, the blue-green deployment. Or maybe that's canary. I always mix them up, but you get what I'm saying.
Yeah.
All right. Thank you so
Cool,
much.
sorry.
For
Going too long.
We're going to take a quick break, about 5 minutes. We have some treats right over here. Grab a cookie, grab something to drink, and then we're going to go with our second speaker, Tony. So don't go too far.
Oh no.
I made a ton
Yeah, I can imagine that's a lot.
Thank you so much for the Good.
Even worse.
You're right behind me.
I'm sorry I didn't
Can you hear me, Tristan?
grill you.
Who's on the other end?
Tony.
Hello?
Good, thank you.
Tony.
Say something, Tony.
I am talking.
All right, we're muted.
Can you hear me now?
On purpose.
Yeah, we want to.
Okay.
So it's not broadcasting.
Is there a? Yeah, there's not. It's not like Zoom
Testing.
where Hangouts has its own volume or
Hello,
Meet
hello?
has its own volume switch.
You okay?
What's that?
You all right?
You alive?
Tell us a funny joke.
And horribly sick for over.
Funny joke. Let's see. Not very long, but I remember when I was in college, my professors used to say there are only two hard problems in computer science: caching, naming things, and off by one errors.
Quick audio check.
Can you hear me?
See, I don't even hear it out of my MacBook. I should be able to hear him right here.
Can you hear me now? I'm talking. Test 1 2 3.
He's talking. You know, idiot check here. Your volume is up right All right, I bet I can hear you now.
Testing 1 2 3.
Yep, I can hear you
Right,
now.
now we can hear you, so it is.
So why did it? Let's see here. Cast this meeting image. Try it again. Caption settings. Customize. Give it a whirl.
Hello? Testing 1 2 3.
So he's coming to my MacBook. Let's see here. Sound. Send it through. Oh, it's going. Shit. No, it's trying to go through Apple TV. that is that one too.
How are we trying?
Yeah, not too bad. Definitely working my work.
Well, I can. So right now I'm just casting via Chrome. But I think I can.
Hold on a second. May I?
Shh. Hold on. I'm going to do this instead. So we're going to screen mirror this. Use I don't want to mirror. So all my notifications are going through.
What you know. It could just like only two like
All right, tell a funny joke.
There are only two hard problems in computer science. Naming things, casting, and off by wires.
Nice. Okay. All right, we can hear you on the big TV now.
All right. Tony, on behalf of all of us here, thank you so much for
and being patient.
Happy to share. Little section here for a second.
Just had to get the right sharing going on. Woo! Run zone. Right. Oh, did he have the face and everything?
I got it. Yep. Well, why don't you guys? It's a one way. Just let me know when you're good, Dale. I'll hear anything anymore.
Yeah, everybody is still mingling, so just give us a minute to catch up.
But I loved it. It was like so fun. Hi everyone. Hello. Hi. Oh, you could come back into the listening area. I like it in the tongue. Slowly but surely. Everybody got a cookie or a drink? Everybody good to go? Ooh, I don't see any thumbs up. Nobody's good to go. All right, thank you again to our first speaker, Tristan. Great talk. And then if our second speaker's ready, I hope, then I'll give it right over to Tony.
Yeah, Tony.
Won't be as good as the first.
All right, Tony, you're up.
You can see everything. So I'm going to be talking about Dagger and unlocking container-based workflows. I'll explain a bit about that in a second. Can you see my mouse?
Yep.
Yes, looks like it. All right.
Your whole browser too.
So a bit about me. I picked up Go, Docker, and Kubernetes within probably the first month each came out, and during college. And from there, I sort of fell into DevOps when I got a PhD in machine learning. I went to teach Watson how to do law at IBM. 5 weeks in, I got laid off, and they had a DevOps role in the office I was embedded in. And I've been doing DevOps-related stuff for about 10 years now. Got into more of the track consulting side. That's how I came to know Tristan. I worked with him at Ferrum. I did Jenkins first, and do a little bit of developer experience and various things related to that now. And my focus has become a lot more developer experience. Encompasses more DevOps traditionally is, a lot of people think of it as infrastructure, but you can get into like CI and then what is the really DevOps is about serving developers and what is their experience. More recently, I've been using two new projects that I think are most interesting in DevOps are Qlang, which is a purpose-built language for configuration, and Dagger, which is what I'll be talking about tonight. And I'm a mega repo fan. In part because of Tristan getting Ferrum to monorepo. I'll just say I call it mega repo because it's not like a Google or Facebook monorepo style. It's just a big repo with a lot of services, and you'll see a little bit of that like in probably some of the examples tonight. But so, what is Dagger? Dagger is an SDK-based front end to build kit, and what that means is you just have language SDKs like any library to build kit. And build kit, if you're not familiar, is the next generation backend for Docker. If you've used Docker build X, it's the successor to build, you're using build kit, and it enhances like the build process to add in more sophisticated caching, a lot better parallelization, and it's lazy. And you could think about it as a DAG, a directed acyclic graph, rather than, if you think about a Docker file, it's a linear thing. And one of the notable things about Dagger is that it's created by the people who built Docker originally, and it's their new take on a developer experience related to building containers and doing much more with it. So yeah, what problems does Dagger solve? Their current tagline is to tame the mess of scripts that ship applications. I think a lot of it is also you want builds that work the same locally and in CI. If you use something like GitHub Actions and you have a local developer experience, and then you ship it off to CI and it's built, with a different set of commands. And one of the goals there is to make it so that CI and your local developers use the exact same commands. It adds a lot to that consistency. But beyond just building containers, you can run workflows in containers. That's one of the aims that people try to use Docker for, but a lot of times local workflows aren't necessarily containerized. A lot of people still run yarn dev and go build and go run. They still use their tools outside of containers. Real quick on how you use Docker from a high level, we'll go into a lot of these things later, but there's a CLI just like Dagger. You're going to just have this Dagger CLI, or like Docker, but you're going to have a CLI like most tools have around. And then there are two main ways you get into a Docker or a Dagger workflow. There's Dagger run, which is more or less you write a program with a main entry point in any of the SDKs. It's just like almost any other program, and you import the Dagger library. And then there's a newer Dagger modules and functions interface. It's currently experimental, and that's what we say is Dagger call. You call a function. That has a lot more of a makefile-like experience, so they're not exactly the same. And then there's the Dagger Cloud UI, which is what they're probably going to monetize. Dagger's an open source project as well. And we'll see a bit about that near the end. But I want to go back to why Dagger instead of Docker files. Docker files are this linear build steps to create an image. You have run, copy, and a whole bunch of stuff. The various Docker predicates you use in a file. One of the limitations, or a few of them, is that there's not good reuse, and it's very difficult to compose segments or sections of a Docker file, where you might have repeated, or you want to parameterize something. There's definitely a developer experience gap there, and you'll see like many steps become these like long shell scripts spread over multiple lines with backslashes. Here we'll see, let me know if this needs to be bigger. If you can't read it, I can zoom in on them. But on the left, we have a Docker file, and on the right, we have Dagger code. And this is TypeScript. And all this is doing is we're doing a Golang builder image. If you want it bigger.
Hey, Tony, we're getting a request to zoom in just slightly, please.
Sure. I'll go one each. So we're gonna see the from statement. I think I got the feeling that people are relatively familiar with Docker and probably Docker files. So this is base image, adding git package. You're copying in the dependency files, or the ones that record the dependencies of a project. And then you typically fetch your dependencies, and you do this so that it's cached. And if you're just changing your application files, you don't have to, this fetching the dependencies is cached for you. And you copy in all your code, you build an application, and then in the Golang world, you can build a from scratch image which has nothing in it, and then you'll copy in your binary from here to here. You create an entry point, and you can see doing it in Dagger is relatively simple. I'll say this client is the handle to the Dagger engine that has a bunch of functions on it, and source is just our code. And so we can create a builder image, it's our base plus git here. And then we have the steps where we do our dependencies. You can notice that it's only, you can include multiple files in one quote unquote line. And then we add our source, then we build our binary. And you can see here, instead we have this binary, we have this file here, we're actually pulling that out and saving it in a variable. And then we can use that variable to place it into another container. And this container without a from is from its scratch. So these are relatively equivalent here in the broader sense. But now we can start breaking it down and pause for a moment just to explain what this config record is. You can think of it as a large configuration object that gets populated at the beginning of your workflow. It comes from, say, hard-coded values, environment-aware configuration, and user flags. A lot of things. This is a pattern I've developed at Ferrum and have used in other places now, where we have this big mega repo configuration object that then gets populated depending on the context of the service it's building or what branch you're on. Anyway, so this common base, we're going to just build a container from some image, but we're going to pass in the platform, because sometimes you might want to build for a different platform than you're currently on. And this pipeline is just a handy way to give a name to a section of Dagger code that follows. But now we can do things like where we had this line where we're adding packages, we can turn that into a function and say, I want to add APK packages to some image, and just list off those packages. And we don't have to remember all this stuff now. And so, And so now we can, I don't scroll without, now we can build a Golang base that starts from a common base. Golang gives it a name and then adds packages to it and then passes it off. And now anybody who wants to build on top of this just calls this function, and they get a image with, it's set up by somebody. There's a predefined standard, and this can help with consistency. And then, it's just showing that we can reuse these functions to build another base. Then we can, getting back to, this is just another example of where some of this stuff can look a lot nicer. If you're doing a Debian-based image with apt-get, you have all of these like slashes that I was talking about, and a lot of times you have these lines at the end of this in Dockerfile script to clean up the cached artifacts from something like apt-get. If you're familiar with how Docker container layers work, if you add something in one layer and then delete it in another layer by saying run, each step in a Dockerfile is a different layer. When you delete it, it doesn't actually get deleted from the image. It just gets removed from the visibility of the outermost layer, the last layer produced in the image. So it still actually exists there. So you see things like this, and with Dagger, we can get this down to a single line when you want to add packages to an image. And this is helpful because you don't have to remember to do all this stuff. And you can actually just run it as a script. One of the reasons I think people don't make these things scripts is because then you have to have that script available in every Docker context. Yeah, so zooming and scrolling is getting to me. But yeah, just so you can this is just a different example with a different packaging system. Then we can start breaking down the different various steps we had in the original Golang example. So we have a prep, and that we're doing the same thing. We're just doing the same steps of adding the dependency management or dependency tracking files, getting our dependencies, then adding all the source. Then we have one where we pass in an image that's already been prepped and just runs go builds. And then you actually, in this case, we're just returning the binary instead of worrying about like what image it's in. Now we just have a handle to that binary that we can then pass into another function and put it into a container and the same stuff. But now what we can do with these kinds of things is we can build a Golang end-to-end function. And we'll get our base, we'll prep our base from the source directory and the name we want. And then we can throw in a test, and then we build, and then we can, I have that, oh yeah. And then, this is where we produce the image, but then we can just publish it as well directly from this function. And so we're getting the build and the publish all in one function, and you don't have to run separate, this would be hidden behind like a single CLI command instead of multiple CLI commands. And then we can go on further and even deploy that application. Another way we might organize this is stepping back a little bit. You could have sort of a registry of your components, very simplified, name, the language, and a repo if you want it. I'm not actually using that here. But then we can, instead of building a single service, we can build a product that's composed of various components, and we'll loop over those components, and depending on the language, we can then build Golang or we can build Python, and then once they're all done building, and in that process, well, the end-to-end process we've tested, maybe we do linting, things like that, then we can deploy it all as one, maybe Helm chart in this case. And we've now gotten this down to, we almost have complete end-to-end CI pipeline for building, testing, linting, pushing, and deploying an image or a set of images down to a single function. And this is all in the goal of taming the mess of scripts we use today to deliver applications. A lot of it is a mix of Bash, Python, Make, Docker files, a whole bunch of tools. And if you've done DevOps, it's a lot of copy pasta and duct tape going on. What Dagger lets us do is start writing a lot of that in the code of our preferred languages, and replacing a lot of this. Like Bash is not a great language. It's not a proper language, let's say, where you have variable scope and things like that. And I guess like a high level comment might be that every software delivery system is unique, and that's okay. And Dagger's letting us get a little bit more control over that with proper languages and SDKs. And DevOps, if you're in DevOps, it's a lot of YAML. We're starting to call ourselves YAML engineering in YAM hell. And I think Dagger's, what I think with Dagger is that we can get CI to be these one-liners where, I can run Dagger builds my project or product or service, and that same one-line command is the same. I just put that one line in CI, and it's the same one line locally. And I think one of the reasons I really like Dagger is because it puts the CI programming back into the user's hands with a real language, rather than YAML with all you see all these logics like when conditions as strings comparing various values with less than, or doesn't string have this as a string in a YAML file. That it just blows my mind that DevOps has come to this. If you're familiar with Helm and authoring Helm templates and charts, you know that doing YAML with Go templates is even worse. some Dagger features that we have going on. There's the DAG itself. It's caching, parallel, and lazy. I guess I didn't really show an example of this yet. One of the nice things about Dagger is that, and build, it's really, BuildKit is powering a lot of this, is that instead of saying these are the entry points to the build, you can say these are the things I want at the end of the build, and it will walk back across the DAG to figure out what needs to be built and what steps to run, and it will figure out if it's already calculated that and cached it through the build kit and how it does file system this, or it's the same idea with Docker and caching. If the files haven't changed, it doesn't necessarily need to run that step. There's caching like that in Dagger on top of build kit. But there's also the ability to specify dedicated caches or user-controlled caches for things like module dependencies or node modules that can then be shared at a logical level across builds and even across services if you want to go that far. Because if you used, if how Go does modules on your local computer, it's sharing a module cache in your home directory across the various Go projects you have. And you can get that same kind of experience and caching and in your CI caching inside of BuildKit and Dagger. And then Dagger itself has a distributed caching product that's experimental where they will provide the caching backend and do a lot of tuning, and it's custom built for Dagger and BuildKit to be even better. There are a concept of services in Dagger, which are a lot like, almost kind of like Docker Compose. You can bring up a service, and this is getting towards the idea of being able to not just build containers, but run containers within a Dagger workflow. And so you can, if you need a database to run testing on your application, you can build your application and then say, here's my database service, and you mount that service to a container. It's sort of like somewhere between Docker Compose and Kubernetes, where you can refer to it by name. And one of the nice things is gets back to the lazy. It only brings up that container when it's actually needed, so you don't have to tell it to turn on, tell it to turn off, these kinds of things. The SDKs have a lot of helpers around, like, do I need to just get something via HTTP? Are there secrets? Like, your build systems have a concept of secrets, and it obfuscates those in the logs. You can now have that in your local build logs as well. There's ways to interact with the host, whether it be file systems, or you want to expose one of the services running in Dagger to the host, or expose a service running on the host into Dagger or Unix sockets, various things like that. And then now there's this newer experience that Dagger's working on around functions and modules that are a lot more make-like and give the ability to say, like, Dagger call github.com birdworm / Daggerverse / like Helm deploy or something like that. Users can now, it's a bit like Docker Hub, but now it's like at a function level where you can have these containerized functions that you can just Docker run or Dagger run. Dagger call, I think, technically. A little bit more about the DAG and some of the kinds of things, where I see this being helpful. And I think this is getting more into like some of the things I've used Dagger to do. If you imagine you have two code bases, you have a front end in JavaScript and a back end in Golang, and you want to then take that front end code, build it as standalone, and then embed it into a Go binary. What does that process look like in a Docker file world? You have probably two Docker files in two different directories, and then you build the front end, and then you have to get the files out of that container and make them available to the Golang container. And if you, as we saw with Dagger, we could build that without having to ever produce an image. We can build an image within the workflow and then like we extract the file, you can extract whole directories and make a file handle that you can then mount or put into another container. And this gets away from needing intermediate images without having to like put something into the when you do Docker images and you see images there. You don't have to create an image or tag an image or anything like that. They can just kind of live in the memory, and if you've already built it once, it'll be live in the cache so that other jobs don't have to rebuild them itself. Then there's this another thing you can do is just when you're testing, I should really find an example of this. I'm probably going to show an example in near the end. I'm going to jump over to GitHub. But you can think of you could build a container based or an image that would have all your testing tools available, and then you can then in a loop just run a new exec on top of that container, and each time the loop comes back around, you have a fresh environment. If you've ever had the experience of having to run tests and clean up before you run the next set of tests, this is something that can remove that pain. I've used it I have a tool that when testing or when it's running for real, it modifies files in the user's home directory. It's not something you want to do on your own system, is start having your tests modify your home directory. So I've migrated that workflow into a Dagger container so that each test then has a fresh home directory to work with without having to do a bunch of cleanup code. I think I already mentioned that you can lazy load services for testing, whether it be a database or whatever service you might need in a testing setup. And one of the other nice things is that you can produce more than one image in a run. If you wanted to build multiple images with Docker today, you have to run multiple commands of Docker, or you have to wrap Docker in some other loop that does that. Now we just have one command. It's all just one unified code base. If you want to learn more about the underlying build kit, DAG, and how merge and diff work, there's a link here. Let's see, what else? What's next? So modules and functions, I'm not talking too much about that tonight. It's a new experimental DX. It's a lot more make-like. You essentially write a class with functions on it with a couple attributes, but it's really about reusable modules composed of functions. And this is where they're really one of the problems with if you start thinking about DevOps and having different builds in different languages. Well, my top level build starts with TypeScript. Well, how do I run a Golang module? I can't import that into JavaScript. Well, these modules and functions are how they're approaching that problem. And so you'll be able to just run another module and the Dagger engine will figure it all out for you. It won't matter what language that's in. It exposes these arguments and such things that the module will need. And modules will be able to pick up on the current build context as well. And I think what it's going to really kind of look like if you used GitHub Actions, there's the GitHub Actions, the project, then there's like actions that you use in GitHub Actions that are produced by GitHub and various community members. Or things like I want to install Trivy to scan my container, or I want to have Docker available on Mac. I think these modules become very much like GitHub Actions that you can use in your Dagger workflows. And so you'll get these kind of very similar idea, I think, in the end. And then there's the Daggerverse, which is going to be like Dagger or Docker Hub for these modules, a set of official and community produced modules that anyone can use and compose and combine. I would say one of the nice things about the Dagger modules compared to like GitHub Actions is that you can't really use at least I've never done it, I haven't seen a way, is you can't use one action inside of another and have them a hierarchy of these things. And with Dagger, you'll be able to do that. Then there's Dagger Cloud. Zoom in a little bit. It's gonna look like any. This is evolving, so this is an older screenshot. There's a new. You can't see it in this. There's a newer experimental UI. What I kind of like about the Dagger Cloud UI is that you have a UI for your build logs when it's in CI, and with Dagger you can also have that same UI for your local builds just by putting your Dagger API key in your environment. The Dagger CLI will then push those build logs up to the cloud. So now your local builds and your cloud builds all look the same as well. And this could be really useful. My build's failing, you just send somebody a link and they can see all the steps going on. I think that's one of the undersold aspects of the Dagger Cloud UI and the Dagger Cloud products. And as I said, they have a cache product that is still experimental, that they're pushing on. Let's see. So some more possibilities with Dagger, or various things you might want to think about, is it's very easy to have incremental adoption with Dagger. It's not like a burn it all down and replace it. It's very easy to piecewise add to and incrementally replace your mess of scripts with Dagger workflows in your preferred language. I think one of the Docker hasn't really lived up to the aspiration of all the things we're going to do are going to be done in containers just in the local development experience. We definitely have gone that way for CI. Docker's all, I think, originally was really about runs the same everywhere, but not necessarily like builds the same everywhere, because most of our local developer workflows are not strictly in containers. So you can now once you move that workflow into containers, you now have that consistent developer environment across projects and repositories, branches, and PRs. And so when a developer, the thing we've had experienced at Ferrum is when you switch between branches, it might be wanting a different version of the software to build that project, be it a Go version or whatnot. And so, because it's not necessarily our local development experience isn't fully containerized. And so this, having it in a container, just getting back to the point that it's bringing that run everywhere the same to the builds everywhere the same. I think I already mentioned you can write files and directories to the host file system. This is, there's an amount of, what do I want to say? You want to build an image and get something out of it. It's like a two-step process in Docker, but you can do this directly in the code and just write things out. And this becomes kind of interesting with Dagger. You could do something if you wanted to write if you ever use like React Create apt, you can do like a Dagger call some GitHub repository with some options, and it will write out the starter code for a new project. And I can imagine there's a ton of things you can do, and it's like a lot easier to write files out from containers to the host file system very easily. You can also, I think I already mentioned, you can access services, not servers, between the host and Dagger. There's a number of different ways to do that. So there's this bi-directional connectivity if you want to enable that. You can do Docker and Dagger if you want. I think I put CI one-liners all over this presentation. This is like an aspirational goal for myself, and I think a lot of people, is to get your CI down to just one line that works both locally and in the cloud. And then there's this really interesting sub-project around Dagger, around being able to run your GitHub actions locally in Dagger. So it will just understand that you have that GitHub directory with workflow files in it, and you'll be able to run that locally. Let's see. And then I have some examples if you want me to dig into any of these things deeper and links to learn more. I think that's all I have. Maybe I'll open it for questions at this point, or I can dive down into some of this stuff. Let me know.
Demo?
So they're asking for a demo.
All right. Let me see. I will. Yeah, I guess let me reshare my screen.
No pressure, Tony.
Hey, before that, should we all let him hear our applause and appreciation?
Okay. Okay, let me see which go here. Some stuff down. Yeah, I've been working on examples today. Sorry, what was that?
I'm being sarcastic. Can you zoom in, please?
Zoom in.
Oh yeah.
Tristan is giving you. He's heckling you.
Let's see. You can actually. I can just. So I have this. This is technically an alias that expects this. Yeah, Dagger directory in wherever you're running it from. Let's see. This is my entry. I'm using the. I haven't migrated to the functions and modules because they're experimental, and I'm not like overly thrilled with the experience. It's got a lot. It's a little bit heavier weight, and I'm adopting this idea that there's like a root script in your repository for your mega repo that developers just use as their entry point to doing things in the repository. So here I'm now trying to at Ferrum we have something called the branch script, which is a Python based stuff. Does a lot of like various things for us at Ferrum with really about like making it so developers don't have to remember all the parameters and flags to things. It picks up on all the current environment and just like figures out the right defaults for them. So we have something similar. I have something similar here. There's, I config a number of like base images across the repository, some external tools I want, registry, things like this, and then per service configuration. I'm surprised Tristan's not heckling me about QAing here. Then there is this. This is the core like CLI. And if I zoom down here, there's just a bunch of flags like what platform, version, registry. If you want to break out of the defaults that it figures out for you, you want to do something specific. And then here's where we're getting into the Dagger stuff, connect client, and build up a bunch of commands. And these components are those, if I go back to here, that's what come down here. There are a number of components. It's essentially a software registry. So when you see something do like DTS build Strappy, it's going to figure out what's going on here. If you're not familiar, Strappy is a open source content management system. Is bootstrap your API and then it turned into a CMS. The only reason I really use it is that, the primary reason I am using it is because it handles figuring out the data. You define the data model and it figures out the database migrations for you. And it has a nice admin UI. But yeah, you can see it's one of the things when you start moving to code-based stuff, you won't see like a linear set of steps in Dagger in a Docker file that you can then map onto like the steps you're watching. And here, and I can go to. We probably can see this running in the cloud because it's running locally. So you can now watch in real time as your service in the cloud as your service builds locally. See the various. But here you can see, I think, some of the stuff we're doing. Here's where I'm adding OpenSSL and apt-get, and doing all that cleanup. This is a Node 20 Slim. The dependencies step, yarn install. Then we add our app and we'll add some environment variables or files. Yarn builds, and then here's where we're grabbing the produced application code. Back here. This yarn takes forever. Here's I'm actually my build step is so I can push an image out. I haven't migrated everything fully over to. I haven't built I would say I haven't built a Docker Compose like experience in Dagger. I think somebody will do that and publish it as a module. But let's see if we can. Where are we at? It's up in here. This is technically what it's doing now. It's taking the container and it's doing an image export. So this is how you would take any container you can export as a tar file. And then I just have some extra code and I think this is where like wrapping Dagger into a CLI tool that also has a much more natural access to the host. You just run commands like docker load that tar and then docker tag. So you can see I'm still like doing things I might do in a make file, but I'm now doing them in code where I have like proper string manipulation functions and variables and whatnot. And then I remove the tar, clean up after myself. That was that. And then I'm not going to show the publish because I'm on a Mac M2 and I need to build a Linux image and that takes a little bit longer because of just virtualization. Let's see. Some other things I think I wanted to show was, I think it's in builders, was mentioning cache. So you can do things like, this is how you can add that shared cache I was talking about. You just have client cache volume. You can just give it any name you want, and then you mount it into any image under a directory, and just sort of it now is shared across all the builds. As long as you use the same name across different functions or what have you, it'll be shared. One thing to be aware of though is that you need to, in particular with like Go, if you're building with different versions of Go, you will end up, or different, if you're doing like a matrix build. I think I have a matrix build in a different project, but you may want to make your cache name take into account, especially in like CI, the Go version and the particular architecture. Otherwise, you're gonna like thrash the hell out of it, and Go is gonna just like constantly be rebuilding if it doesn't break your stuff altogether. What else might we want to see? Yes, my publish is very similar. Well, I guess I could walk back, right? I have these. Where is it? I had that config and CLI, and then I have. That's the commands. This is the one I want. I have a number of images I'm building, and so I'm returning all these images, right? But I only built the Strappy one, and that's when I was up in this build, and I said, let's see. where is that loop? Okay. The config components. I guess the components is a default of all of them, or when I said BTS build strap, yeah, I just said I only want to build that one. I could also do like web app here. I would just build those two components. But if we go back, this is getting at that laziness. You know, I can put together all the like images and builds and then export in this big object, but it will only, where did it go? Build the ones I actually requested by doing this output, which is doing the, when I get to something like image export, there's a certain, I think there's like 3 functions that force a DAG to execute to that point. It's export, publish, and there's a sync command for manual. And then if you look at publish, it's not too different. We're just looping over, and instead we're just calling the publish function instead of export. But it's the same list of images that we get. Then deploy. I'm doing some craziness with deploy where I do queue. And run that. I think I'm actually just running this in host. I haven't containerized this completely yet. But you know, getting back to it, you know, it's all in one language now, and we've got this tool that I can now, like, if I wanted to containerize this, or when I get to it, I should say, I will do that.
Thanks, Tony.
Good job, Tony. Thank you very much. Oh, we lost our MC.
We lost our MC, so I'll step up real quick. Awesome. All right, so one more big round of applause for all of our various speakers. All right, cool. So, did y'all have fun tonight?
Yeah.
Did y'all enjoy the talks?
Yeah.
Did you enjoy the tacos? Did you enjoy John's baklava? Thank you for bringing that tonight, too. Yeah, huge. Awesome. Cool. So, as you know, we do this on the second Tuesday of every month. We'd love to have you back. Please keep coming back. We're here on the Meetup. Also, yeah, sorry I took over. You stepped off. Yeah. Also, we are always looking for more speakers. If you think you have a talk in you, whether it be like something heavy and robust, like some of the talks we've seen tonight, or just a 5-minute, hey, here's my fancy toy project where I hacked my remote to, you know, remote control my Roomba or something cool like that. You want to tell us about it. We want to hear from you. Sign up on the Discord or come see any of your organizers. Organizers, make yourself known. Woo! There we go. Cool. Come see any of us, and we'd love to hear from you. Other than that, we're going to hang out for like another half hour before I start shoving you out the door. So please stick around, eat some more tacos, drink some more beer and sodas, and have a wonderful rest of your evening. Thank you for coming.